Dear audience, my name is Dilan, Márk, Karim. I work here at the university as an anesthesiology resident, and my vision is that science may overcome quickery, and for that now I want to learn better and better and understand better and better the beauty and pitfalls of evidence creation, and then disseminate it how to do it nicer. I have several ongoing projects, out of which the first two is related to microbiome research in the critically ill. The first one serves us now as an umbrella project for further research. And in the second one, I examined the lower respiratory microbiome testing sampling methods. So in the first umbrella project, I'm investigating dysbiosis in the critically ill. And the problem on this field is that we know that in critical illness there can be extreme dysbiosis, which is related to morbidity and mortality, but we don't really know exactly the factors that are affecting diversity and the extent diversity loss during critical illness. So our aim was to analyze this, and our hypothesis was that dysbiosis is very frequent and extensive during critical illness, and there are distinct factors that we can measure which are affecting it. So after a very exhaustive meta-analysis and selection process, our results came back, lots of results. The largest database ever created on the topic was made, but the problem was that, as usually appearing with meta-analysis, that the differences did not allow a real comparison, because the between paper differences were higher than the differences that we wanted to measure. So these results represented methodological differences, maybe not the real outcomes that we were looking for. Just to highlight this for you, on this graph you can see how diversity on y-axis changes over time during the critical illness in different publications. And you can see that there is a significant change in diversity measured by the studies, but the differences between studies are so much higher they are not comparable, and it's a big problem. So it wouldn't be nice to just pull them together and say anything. And also all the effects, all the interactions that we were looking for cannot be examined on this pool microbiome data, because antibiotic therapy, for example, of course it affects diversity, but with these pooled methods we cannot say any solid interaction is there. So on the way to improve this comparability, we move forward. We first used standardized diversity indices, and this means all papers where there was no healthy control groups, to make it serve as an internal control for the scale. And with this, between paper differences were somewhat eliminated, but it came with a great reduction in power. However, the thing that we can say based on this analysis is that the diversity is significantly reduced in the critically ill. Towards the left, towards the left you can see that diversity is higher in controls, and all ICU patients' diversity was reduced. And this difference was similar among adults and children. On other diversity indicators like richness indicator, we got similar results. So we can say that this standardized comparison is more reliable, but it comes with a lot of loss in power. But to answer our initial questions, we would still need a larger analysis with more reliable results. And to do that, we are now reanalyzing and obtaining raw sequence data from online data repositories to build an individual patient data meta-analysis. And in this way, independently from the original studies, we can ask our questions from these databases, and between study differences are eliminated, and that is considered the highest level of evidence due to Cochrane. The bioinformatics took us some time, but now we are building our own algorithm to reanalyze all the raw sequence data which is in the repositories. And parallel to this, to support our results, we are taking samples from our ICU patients. A lot of samples are already taken and sequenced by the Micro Institute, and data is just pouring in. So we can say that from a raw comparison of pool data, we are building a reanalyzation of raw data, and we are building a model to support with our own ICU's experience. And this initiative to build a standardized microbiome research framework was just this week shown in the Scholars of Sepsis conference. In my second project, we are exploring the difference between tracheal sampling and bronchoalveolar lavage sampling to evaluate this microbiome diversity. Because pneumonia is a huge problem and a big burden on healthcare, and to diagnose and manage pneumonia well, you need very good quality samples. And you can either go with an invasive bronchoalveolar lavage to obtain a sample, or less invasive tracheal sampling methods. And when you have the sample, usually what we do is to identify the pathogen bacteria there. We use culture-based techniques, but the possibility is just opened lately to see the whole landscape of the microbiome there, where both non-viral and non-pathogenic or also inactive bacteria are there and can be analyzed. And many studies compared the lavage and the tracheal sampling methods based on culturing results, but no systematic comparison was done based on these metagenomic sequencing results. So our aim was to do that. And our hypothesis is that there is no difference between the two sampling techniques results when assessing diversity with this metagenomic sequencing. So our hypothetical forest plot was about to look like something like this. The difference between diversity doesn't tend to be higher favoring ball or tracheal aspiration samples. And if that is true, and there is no difference in diversity between the sampling techniques, it's better not to do the more invasive and resource-intensive method. So after systematic research and selection, we had 5 studies. And as we anticipated, there was no clinically or statistically relevant difference when measured the diversity of samples obtained by these two techniques. I want to highlight here this heterogeneity data, which is always sometimes very high, sometimes very low, but it's mainly because in these studies, because of the low number of included studies. That can be the case here as well, but these 3 studies are assessing very homogeneous critically ill ICU patients, and I'm pretty sure that we are measuring here the same effect really, not only the low number of included study effects. However, all other diversity index showed similar results, that there is no difference in the sampling method measured diversity or richness. And if that's true, we recommend against to perform a bronchoalveolar lavage. I have some time, so just some words about the risk of bias analysis. As you know that choosing a relevant tool which is adapted to a specific studies design is essential. It's a very subjective thing to do a risk of bias analysis, and if it's not adapted well, that the added value is not so much. And in our design, we were comparing samples obtained from the same patients at the same time. So most of items in traditional risk of bias tools were mostly irrelevant. We needed to ensure the quality of the sampling method and its homogeneity between studies. So I conducted a literature review, defined the most important parameters as source of bias based on this, did a checklist based on this evidence, and I sorted all these new items in 4 domains, 2 super domains, and the results of my own risk of bias tool analysis is similar to previous ones, but it's much more effective. Manuscript is under internal review now, but I would be happy to publish it in the microbiome. Thank you for your interest.
What is the therapeutic consequence of these microbiome studies? What can be done to?
Yeah, that's the main area of interest for the future and why we don't want to understand it. but it's somewhere in the phase, as I see, how originally Dalton was measuring the blood pressure of the horse. There is a blood pressure difference when the horse stands up or sits down. I think that we are someone there understanding the microbiome. We don't know how to influence what species and what happens if we influence it. There are some trials, probiotics, high fiber intake, but unfortunately they are not giving very good results.
Thank you.
Thank you, very nice work. I really appreciate the wide angle of your first project. So as I understood, you collected samples or data from all microbiome types, from fecal, urine, which kinds were there?
Yeah, I dismissed the skin. I collected skin, but data was very scarce on that. But lower microbiome testing, gut microbiome diversity, and blood microbiome diversity are the main focus of research nowadays. Blood is very emerging.
So, and you would then compare the microbiome patterns in between the same samples, I think, or would you like to make comparisons between fecal and bronchial?
Yeah, no, for meta-analyzing, they are completely different territories. So, but they can be included in different analyses. Very high diversity is good in the gut, but very bad in the lower respiratory system. But we can collect them and we can reanalyze them, but they are going to be separate domains. But in our study, we are collecting the same samples, the same 3 samples parallel from the patients at different time points. And what we anticipate to see is that there is a migration between microbiome patterns between those entities from the gut to the lung, maybe, and that can be an engine of sepsis, maybe.
And how is the dysbiosis defined in these studies? Because it might be also this endpoint very, very diverse.
Yeah, of course. Now a general definition can be said that in our microbial communities, they are quite stable, and if any harm is present to us or to them, a loss of diversity and the change in composition happens, and that's what we call dysbiosis. And the change in composition can be analyzed with mathematical methods, but the diversity indices are depicting the diversity change well or not well, that we will see, but they are the most used parameters, this Shannon index, KO1 index, and other diversity indices. So maybe diversity change is one part, but that's easy to examine.
Okay, and I missed on your slide the number of eligible papers for data extraction for the first project. How many are there?
It was 1,800, so 18,000.
Yes, but how many were at the end eligible for data extraction?
137.
Okay, so
it
still
was
a huge number.
Huge work of data extraction, but I would not have a good gut feeling just publishing that pool data, because a lot of meta-analyses are crap on the market, and that would have been another one.
I'm curious, do you believe that orally taken probiotics might increase the vaginal flora, or it has any effect on it?
I read some studies. Data is very inconsistent, and the evidence quality is just so low. I don't know. But what I do know is that on-market products were assessed by the Microbiology Institute, for example, and they were sequencing how many living bacteria is on those products, which are for restoring vaginal microbiome. And basically all of the products were lacking living bacteria in them. So most of it is just let's say it nicely, it's not working. Maybe your vaginal rings are a better option, because enhancing hormonal activity higher, overstimulating estrogen, can enhance the production of lactate and lactobacillus activity.
Thank you. I was just always thinking about this, taking something orally into this. Okay. So.
but also vaginal lactobacilli products were not working that much.